hello. Today we will be talking about Neo4j and graph databases. I will say this talk is centered primarily around Neo4j, but the concepts that we learn here can pretty much be used with any graph database. I chose Neo4j because that's just what we work with at work, so it's what I'm familiar with. So, and also, if you have questions at any point, please just shout it out or raise your hand. I love answering questions and getting feedback. So if you have one, say something. Don't feel bad about stopping me. So a little bit about myself, because I see some faces here that I don't know. My name is Ryan Coleman. My pronouns are they, them. If you're wondering why that's important, you can come talk to me after the talk. I'd be happy to discuss that with you. I am a senior developer analyst at Merits Motivation. People ask us a lot what we do at Merits, and it's kind of hard to describe, but in general, we're a professional services company. So we work with a lot of Fortune 500 companies, and we do a lot of their incentive programs, employee engagement, all sorts of stuff. You can find me online. Here, I hate saying that out loud. It's RYUHHNN, or my website. You can find me on STL Tech at that handle. You can find me on Twitter. Send me a message if you have questions. You're welcome to email me or reach out to me via my website. This is where I have to interject the views and opinions and judgments expressed in here are that of my own and don't reflect that of Merits. Without further ado, I would love to show you this video. I've been waiting for this meme to become relevant, and I hope that it plays the first time I try. Look at this I love that video because he's just so nonchalant, and I don't know. I just think it's hilarious. And I've been waiting for that to become relevant, and it is. So to start out, data is complex. We all know this. Data for any sort of use case is it's hard. It's hard to think about. It's hard to organize. It's hard to categorize. Data is just super, super complex. So a little brief history of the database. We've kind of come a long way when it comes to data storage and retrieval. Started out way, 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 way back in the day with punch cards and actually putting holes in paper and then reading those holes, and then we indexed those, and then we had these giant rooms of all of this paper. And then we found out that technology can help us, and we got relational database management systems, and you've got time series databases, NoSQL, and then graph databases. So all of these together are just ways that we can store and retrieve our data. And they're all kind of used for different things, and they all kind of fit into their niches. Relational databases we know are good for transactional storage, and then NoSQL databases is good for just blob storage of objects and documents. Graph databases, which is what we're going to talk about today, kind of have a very special and I would say generalized use case where you can use them for a lot of different things, and we'll talk about that more later. So if you're coming from the SQL world, you'll know that storing databases or storing data of any type is kind of tricky when you need to relate it together. This comes really in any way that you, any sort of data you would want to store, whether it be employee information or transactions or products. You put them in all of these tables, and then you have to figure out, where is that data? What table is it in? How can I link these two tables together? How can I pull some data and display it in a way? And then you get this long, complicated SQL query, which all this is doing is returning all the information about an employee. So if you look at this, trying to engineer all of these joins for all of these tables and all of this data is super, super complicated when all I want to find out is the information about my employees. It's a really bad way of doing things, and it is a way, but I wouldn't necessarily call it the right way. And then you have people that talk about like MongoDB, and well, it's not web scale. Like if you go to this website, it's actually a pretty hilarious transcript of a talk about someone just ranting about how terrible MongoDB is. I will just plug though that MongoDB does support ACID transactions, so there's lots of people out there that like to hate on Mongo. It's got its uses, but yep, some people will still hate on it. So I would like to propose that in a lot of ways, nature inspires art and technology, and it's time that we start thinking about how we model our data. on my GitHub. So I will pull that up really quick, and then Google Chrome. So if you go to my GitHub, which is github.com/ryuhhnn, and go to my repositories, it should be this first one, netstackrn. So you're welcome to clone that and work with me. If you don't have your laptop, that's totally okay. I'm going to work through this all on the screen. But maybe if you guys want to like get together, you're welcome to pair with each other. So this will be like the fun interactive part. So yeah, if you have Docker installed on your computer, you're going to be in for a good time. If you have NPM installed on your computer and Node, you're going to be in for a great time. If you don't have either of those downloaded, you're welcome to do so now. They do have free Wi-Fi. They're so generous. So the CIC Wi-Fi, you're welcome to connect to that and download all of this stuff. And if I leave you behind, I'm sorry, but I'm going to go ahead and work through this with everybody. So whenever you clone this down, and I need to remember where I put it. I promise I'll make all of this bigger. That should be big enough. All right, so whenever you clone all of this down, I've got 2 sections of this little demo app. There's a front end and a back end. To start up the back end, first run npm install. I won't run that because, well, I guess I can run it again. It's not going to make a difference. So run an npm install. It's going to download all the dependencies. And if you have Docker installed, you can just run Docker compose upd, and we now have a running Neo4j instance. Yay! If you don't, there are setup instructions on the Neo4j website. Super, super easy to set up. I won't go through that though, just for sake of brevity. But if you have Docker, just run Docker compose up. And then npm start will start that server. I'm going to open up the front end just so I have something to show you. All right, so this little demo app that I built is kind of more geared towards my mom, who is actually not here, ironically. It is a root cause analysis, a very poor root cause analysis app that I threw together in a couple of days. So very, very rudimentary, but hopefully when we go through this, you'll kind of see a practical use of Neo4j. Another cool thing that Neo4j has is this like visualizer. This is like one of the best like visualizer tools I've ever used for a database. So just like a quick overview, what this does is we can add a device, and then we've got this list of devices, and we have types for them, what their status is, and then an ID. We can edit them, and then we can define a connection between 2 of those nodes. I know nothing about networking outside of like one class that I took in college that I dropped out of, so that probably doesn't make sense, but in my mind this is like how networks work. So right now it looks like the whole network should be offline because I turned the hub off, but if you want to visualize what that looks like in a graph, we have this amazing visualization. Just comes like ready already with Neo4j. I just think it's amazing. And we can explore these nodes. So if I click on one of these, I see that this is Network Hub US Central 1. Its status is offline, and it is of type hub, and it's got an ID. And it connects to this network switch that is somehow online. And then that switch connects to some residential connections. So we'll go in here and start off first by powering that bad boy back on. So now we're back online, per se. So if I add a device, I'll just call this like, did I spell that right? Residential connection, and I'm gonna put it at like some random number. Let's say this person's got a wired device, and it is currently online. Cool. So now let's define that relationship. I can hook that up to, let's put that on network switch 2, and wire that up. So now if we go back here and find, let's see, network switch 2, which is somewhere in here. I think it's right here. That's network switch 1. That's our hub. It's one of these. There we go, network switch 2. And it connects to our residential connection, which we just made. So let's go through and walk through some of the code to see what's happening here. I won't really show most of the front end code because I feel like we might all be familiar with that. I wrote this in Node and Express. Hopefully everyone here knows JavaScript in some capacity. If you don't, syntax is pretty simple, so you should be able to follow along pretty well.
Make your font just, there you go.
Yeah, I might make it bigger. I was just about ready to get there. So there is a Neo4j driver for Node. I had no problems using it. It works pretty great. I don't know, is there like an ORM out there for Node and Neo4j that you can think of off the top of your head? I'm thinking like Mongoose for Node and like MongoDB, and then there's that like Sequelize, I think, for.
I'm pretty sure there is. I have to ask somebody who's more adept at JavaScript than I am.
Sure, no, that's fair. Okay, so this might not be the best way to do it, but just to kind of show you these raw queries that we're doing, this driver does pretty good at that. So first, when we add a device, we're going to come up with an ID on the fly, and then we are going to get the name, type, and status out of the request body. And then we are going to use our Neo4j driver to run this query. So this query is going to create a device that's got an ID of that ID that we just created, a name of that name that we just created, tag status. It's going to run that query. It's going to close the session, and then at the end, I'm returning A. So really, I'm just returning that device that I just created. So when I create one, I get it back.
Does the run method do, or is there a worry about like data sanitization in Neo4j? Like thinking like.
There are like a list of types that are supported in Neo4j properties. As far as sanitization goes, I would assume that if you pass in the correct data to it, then it's going to store that. But outside of that, that sounds more like an application level concern.
Like if my if in name I put in like the characters to close out whatever Neo4j query could be in there, and then write my own query to like say drop everything in this particular.
Oh, were you thinking in terms of like SQL injection?
Like,
oh, okay.
Neo4j or?
That's a good question. How would you perform a SQL or Cipher injection on Neo4j? Is that a concern for our Neo4j friend in the crowd?
I've honestly never had that question raised.
Yeah, that's a really interesting question.
Take down Neo.
I'm hacking down. Sorry.
Yeah, I will say on some of the, so the driver website lists this as the specified way of running these queries. You'll notice in some of them I'm using template literals and string interpolation. That's probably a bad practice. This is one of those, I don't know. But for demo purposes, it works.
Sure.
So yeah, that's a really good question. So for our device list, the query for returning all devices literally could not get any simpler. I just match all nodes that are devices, and then return it. Right now, with my database having the data that it has in it, I don't even need to specify that that node is a device, since the only nodes that are in my database right now are devices. And you can see that actually in this Explorer. I don't know the official name of this, but you can see these node labels that I have. And then you can also see these relationship types. So like here, I can match everything, like match every node that has a relationship that connects to another node. So that's another really cool thing. We also have like property keys in here. I've never ran this actually. Oh, okay. So
what does the table version look like?
it looks like this.
Okay.
So if you're coming from MongoDB, this might look a little familiar to you. These are, like in this table view, it's just simple objects. And in our code, this driver has a method to get and also a method for, where did it go? I know it's in here somewhere. A method for returning it to object. Yeah, there we go. Yeah, so there's different ways that you can return that data. The way that it gets returned, just vanilla without its extra processing, is kind of funky looking, but you can use the built-in methods to kind of normalize that a little bit.
With that plain match category, you're returning all the devices. So that result set, when you look at an individual device, that result has all of the properties associated with that device and their values and all the relationships too. Like, would that query essentially return all the data in the database in that result set?
Yes. So like if I run this same exact query in my Explorer, it's going to return all of my nodes and all of their connections. This driver specifically, you have to tell it in like how it shapes that data when it comes back to you. And actually, I do have an example of that. So get by ID, get relationships. That's not the one, is it? Yeah, it is. So if I'm getting relationships by ID, if I want to get the children of a node, I can match a node that has another node that connects to that node. So this here would be the child in this case, and this here would be the parent. The parent connects to this child node. And then I'm matching where this parent ID or parent node's ID is equal to a certain string, and then I'm returning both the child node, that relationship, and the parent node. And then in my results, I'm pushing it into a certain structure. So I send it back as a single JSON object that's got the node, which would be the parent node, and then an array of that children, or of those children. So like the visual example of that would be when I go to edit my Network Hub Central, I get all three of its children. Its direct children, because that's all I asked for. So yeah, there is getting it by ID. Connecting two devices, super simple. All we do is we match a parent device and a child device where the parent's ID is this ID and the child's ID is this ID. And then the parent connects to the child. And again, this is a directed relationship. So since the arrow is pointing that way, the parent is connecting to that child. And then we're returning that relationship. So here is where that comes into place. I know someone had asked earlier about like what these little thingies mean. So this pointer, we're returning that relationship in this case. And then we could also add in other like properties to this relationship, like connects downstream to, or I didn't put that in there because it's kind of clear that it's connecting downstream with that arrow, but so there's that. And then we can get the status of a device, or we can set the status of a device by simply setting. So this little set keyword, we can match a device by a certain ID, and then we can set its status just like that. and then return that device back. So this is where the question of like, people say, well, we're schema-less, but like what happens when we have this big glob of data and then we want to make it look like this glob of data? Well, you can just query for the nodes in question, and then you can run this set and then set whatever properties or unset some properties and then return those back. So you no longer have to worry about normalizing this data in both places and figuring out all of that mapping. You can simply just run these queries and it'll produce those on the fly. So super, super cool. And a lot of these are super simple. If these were SQL queries, they would be much longer. So yeah, any questions about like what's going on here? Anything? No? It's super quiet. Okay. So who wants to play around with this? Let's play around with some nodes. This is where I do this like kind of pseudo live coding thing. I'm terrible at like live coding in front of people, but how can we, or what kind of data can we produce, and what kind of relationships can we produce out of these? So let's think of like some real world stuff. What is some data that you work with day to day? What's a node that we can create?
Like related to this, or just any?
Just anything in general. It doesn't even have to be this. So, and actually, I'd love for it to be unrelated, just to show you like how I can query, nodes of different types.
I mean, can we do this meetup group, like members and?
Sure, we can do that. So we can create like a group node, and
Sure.
let me pull back up this slide with my nice little.
Unless somebody else has something they'd rather.
So yeah, for creating a node, let's create a group. So we run this create, and again, our nodes are represented by these parentheses. I'm going to label this as being a group, and the name of that group will be, is it STL full stack?
Yeah.
STL full, it's all one word.
All one word.
FullStackers.
Pretty glad we renamed it.
Yeah.
St. Louis full stack web development and other stuff.
Full stack meetup group. I'm just gonna call it meetup group.
I was just messing with you.
All right, so if we, and then we can return that back if we really want to. If I give it a little. So there we go. We have created a node. That is the name of STL full stack meetup group. Now let's create a person. Let's create Chris. We're going to create Chris, who is a person, I think. Might be a robot masquerading around as a person.
Never does. Until it's too late.
And do we want to put you in that group? Yeah, let's put you in that group. So let's define a relationship. What can we call this relationship?
Organizer.
Oh, that's a good thing. Ugh, that pained me to type. Organizes, and then that node is the group whose name is the STL full stack meetup group. And I probably can do this another way. This is where that like typing thing. Oh, what happened to my thing?
Can you do the up arrow to grab? Or it's like, or up and down.
Oh.
Through.
Maybe. Oh no, it went away. Let's just create you first. We're going to create a person whose name is Chris.
2.0.
Let's make sure we get him back. There we go. Okay. And then if you want to go back and reference that code, how do we create that connection? Aha. So let's match these two first. So we're going to match our person, Chris, and then we're matching that group. Full stacker, did I call it stackers? Full stack meetup group. I'm missing something.
The
And a quote.
Yeah.
There we go. So now we can just say where that, well actually I don't need to do that. So let's create that relationship. So we're gonna create our P here in this case is gonna be our person Chris. And this is going to be a directed relationship, organizes. That group. And then let's return both, or all of these nodes really. RG. Let's hope I did that right. Yay! It worked, first time. So Chris organizes the full stack meetup group, SCL full stack meetup group.
So with this query, what would have happened if you hadn't specified the meetup group? Like if you grab the whole thing and remove meetup group from it, like would you get an error?
So for that one,
Oh, I'm not even talking like removing the meetup group, because like in that case, it would like create the relationship to all groups, right? I'm talking like if you specify name and the name was full stack meetup group, but you put in full stack only, like would you get an error message because that group doesn't exist?
Right. So for this one, and you'll see that it created another connection. You can have multiple connections coming from these nodes, but if I specify one that it doesn't find, so let's do that. Name the group is equal to like cheese. That was the first thing that pops into my head. Nothing happens because it's not going to match that node. So, yeah, nothing will happen because you can't match that.
If there were multiple person nodes named Chris, each one of them would give a relationship to that group.
Are there like wildcard searches like if
Yep. So I actually have my example of something like that, where I want to find like all of the upstream nodes in this network. So I have it saved here actually. Oh, what's this little thing say? Product between two. Oh wow, that's a lot. I had this in here. Oh no, it must not be in my history anymore. But what you can do is, let's find that node first. Let's look for choices. So let's look for a very downstream node. This one, that one looks good. So this node's ID is this long string of characters. So I first want to match this node that is a device whose ID is equal to that. Okay, and I want to get all of its upstream nodes. I think this is the syntax for it. I'm going off of memory. Connects to device. I did do it. Oh, I didn't return anything. That's why. And then I want to find. And then let's return that. Oh, no, it's the opposite. I want to return not this one, but these. Is it? Oh, come on. Hold on. It's one of these. Am I returning the relationship? I know this is in my search history. Aha. Maybe not. Return NR. Okay, I feel like this is something wrong with my return. So let's return D1. Okay, well, this is the while. There's,
It's a star in the middle. You don't need the dot dot unless you're gonna create a limit somewhere.
oh yeah, the dot dot, you can spread it up to like, or I don't know if that's the correct terminology, but I can find the 25 upstream nodes with that relationship. That would be that, but yeah, you're right, I only need that.
But with this, I mean,
The relationship should go the other direction, shouldn't it?
Ah, I think you're onto something. What to return? Yeah, I think I only want this one, don't I? Aha, there we go. That's right. See, this is where that, where's my downstream node? This one. Yep, so there's our residential device, and then here are all of its upstream nodes. So you can see how, like, in a root cause analysis scenario, if I query for the nodes upstream from a device that are offline, I can easily pinpoint the place where that happens. So I can trace this all the way back up. So this wireless access point connects to this router, connects to that modem, connects to that switch, connects to this hub, which right now it's online, but if I trace that back up and find the first one that's offline, boom, there I solved my network problem. So that's like a real world scenario of like a query that you could run to find nodes in that graph.
so in this, I mean, your example here, right, there's only one type of relationship between the nodes. that
Correct.
connect relationship. If you had a situation where there were different kinds of relationships between different nodes, with your query that had the star in there, that's going to match against any kind of relationship and any length of relationship.
Right, so this query, because I've got this like star, it's gonna match any any relationship that these nodes have. So regardless of whether that's like connected to, so like I could really put connected to here and it wouldn't change the, oh, maybe it does change.
It's like it's doing two things, it seems. It's matching all kinds of relationships, but also matching more, like length, a sequence of that relationship. I'm just curious as how you could say, well, I want the connects relationship, but any length of any sequence of related nodes, or the other way to cut it would be, well, I don't care about the relationship, I only want it to be length one.
Yeah, and so if I want like
Possible.
maybe the two most upstream nodes, or the one most upstream node, I can put that 2 in there, and that's gonna limit that to 2 nodes.
Okay, and then how would you limit it to a particular type of relationship?
Ooh, it would go somewhere in here. I don't know where that would go.
You can do the colon relationship type and then specify how many hops you want it to do.
Colon relationship dot dot.
So you
two.
can do a colon connected to star and return all connected to relationships any number of hops away.
Yeah. Good questions. Any other questions about like queries or data or nodes, graphs, Neo4j's, ciphers? Any questions at all? No?
Does Neo4j, can it be sharded or distributed, or does it have to reside on a single?
Yes, it can be sharded
Yeah.
and distributed. I can't speak too much to that, but I know that it has that capability.
Okay.
It's, yeah. Something cool to point out too, any Java people in the room? Yeah? I kind of figured. So Neo4j was written in Java, so there is a language, like extension or driver, I don't know what that correct terminology would be, but you can actually, if you use the Java language, this part of it, you can determine how it traverses a graph. You can determine like that. So if you like really want to performance tune something, you actually can dig down into the like internal APIs of Neo4j and determine how it traverses a graph. I think right now from the training video I watched from them that that's the only way you can do that right now. But there are drivers for most any language out there. So you're really not limited by language drivers here. A lot of them are community supported. But the official one, I guess, would probably be the Java one since it's written in Java. Cool. Any other questions, comments, concerns, thoughts?
I know when I played around with Neo4j maybe like 3-4 years ago, there were, I think, max limits on like the number of nodes and the number of relationships you could have. Is that still the case, do you know? Or?
I don't know. That's a good question.
Limits are gone.
Yep, no
Really,
limits.
it's about your hardware. So you have to have good memory and good heat. Because, I mean, you can build massive machines and because of how good storage is and all that, we used to have limits beyond.
How do you reset the password on your example, because I can't get in? Like I have it launched and everything like that, but I can't actually go to the browser and get in.
There's a password?
Yeah.
There shouldn't
Maybe
be.
we can look at it after.
Sure. If you do load this, there won't be data in it though, so you'll have to load your own data into there. I pre-populated this with some data before I came here, but yeah, you're like super welcome to play around with this. If you feel so inclined, you're welcome to submit a PR. But yeah, I put that out there for you all to have fun with and explore Neo4j, specifically with Node. So really, like, what do you do now? In full transparency, I derived a lot of this content from the official Neo4j training videos, which are all on YouTube. They're 100% free, minus your time spent watching a 15-second ad that you'll probably skip. So go watch those. They are super, super, super helpful. They explain it probably a million times better than I could. But honestly, I would start there. That'll answer 99% of your questions, I'm sure of it. If you have other questions, I hate to be that person that's like, just go to their website, but just go to their website. They have a super, super good documentation. They document all their language drivers. Most of them have examples too. There's one out there for Node that's like a movie database, so it'll show you like, actors that acted in these movies, and then like directors that directed these movies but acted in these. So really, really cool examples out there. They do also offer a training course on their website. I don't know if you have to pay for it. I didn't really care to sign up for it, but maybe you might be into that. So look into that. If you have questions about this, obviously you're welcome to come talk to me afterwards. I'm in STL Tech again under that handle. And like I said, feel free to reach out to me at any time, any way. You can reach me online. Come talk to me. Other than that, that's my talk, unless anyone has any final questions.
Yeah, I saw they call it the Bolt driver, right? So is that the driver?
Yeah, Bolt, I think is like their, and you can probably explain this better, but like the mechanism at which they use to talk with the services. So it's like the...
So I saw all the language drivers seem to be called Bolt. Right?
They all use Bolt,
Yeah, so
and they implement Bolt, I guess I should say.
So is that a protocol or something?
Yeah, it's the protocol at which you access the graph. Yeah, and there was one out there, I wanted to do this in Rust, but the Rust driver just wasn't quite there and usable at that point, so, but, yeah.
And where is Neo4j store the data? Is that...
So if you go to that repository, I'm storing all of it just there locally, so you can actually go in there and look. Right now it's storing everything in graph.db. These are binary files, so I can't really open them up to show you what they look like, but yeah, you're welcome to go in there and check it out.
So how does it do the storage different if it's a cluster?
When it comes to under the hood stuff, I would have no idea. And to me, it's magic. It is pretty magical, actually, but under the hood, it works the same way as it's graph theory. At its core, it's just graph theory. Yeah, and that's another thing. If you haven't like read into graph theory or like that I can't remember the exact name of it, but like Euler had that thing with the bridges and finding the closest or the way to like cross all the bridges only once.
7 bridges of Königsberg.
Yeah, that. If you haven't like read into that, do so, because like when you read into graph theory, it'll like change the way that you think about data. Seriously, like this is like game-changing stuff. Like I feel like the industry is so behind when it comes to the way we've stored our data. So we've been like, oh, big data, just put it in a NoSQL database. Then how do you traverse that? How do you relate that data? So I feel like we're all so behind the times. But yeah, take this, go to your work and be like, hey, stop doing what you're doing and use Neo4j. I probably shouldn't talk about like proprietary stuff, but we use Neo4j to store hierarchies of like employees and their like bosses and managers, and like we group them together because companies are complex. They have, multiple departments, and then they're spread across the country. So that's how we utilize Neo4j at Merits, is we store hierarchical information in a graph.
Is the query language essentially like a standard in any graph language? Just
Yeah.
a particular implementation to actually store the data?
Yeah, so Cypher is actually part of the OpenCypher project, and OpenCypher is like the specification for the Cypher language. Neo4j uses it, and there's one, I can't remember the other name of it, but there's another one out there that uses almost like verbatim what Cypher and Neo4j is in their database drivers. But a lot of the other graph databases out there use some sort of hybrid query language that is Cypher, but with their own little stuff mixed in. So you'll find probably a couple different permutations of Cypher, but for the most part, they all follow the OpenCypher.
Not quite standardized.
Sure, yeah, and there's a website out there somewhere. If you Google OpenCypher, it'll show you like the specification for it.
Sounds like it's like SQL in that respect. Everybody has their own flavor.
Yeah, precisely.
So other, like Neo4j alternatives, I know like OrientDB is one.
Yeah.
Are there any others that you've come
I
across?
actually just had one that I looked up.
Sorry.
Yeah, totally here to tell you dgraph. Dgraph is the other one that seems to have a lot of community support. That one was written in Go, if that interests you. That one I've seen a lot of community usage around. So yeah, again, like these concepts apply to all of the graph databases that are out there. They function pretty similarly. Neo4j just seems to have the best community around it. They've got the best documentation.
Yeah, it seems like it's best in breed.
Yeah.
And does this database needs any indexing like we have in our other kind of databases?
So you don't need to index the data. I think that you don't have to at all, actually, right?
So indexes work a little differently in Neo4j than they do SQL. So SQL, it uses it to basically find the paths and do the lookups. With Neo4j, indexes are used for your starting point of the query. So it locates where in my graph do I start, and then traverse the relationships from there. So you don't do lookups. You follow, and I can go into a little bit more detail. Somebody else catch me after, but the internals of it basically just do it's almost like a linked list type of deal where it jumps from node to relationship to node, and it knows what path to traverse because it knows what nodes are connected to relationships. If that makes sense.
So then would you only be indexing nodes? You would never index like properties on relationships? Or?
You don't index properties on relationships right now. We're working on that though.
Cool.
Interesting. What was that?
So, is there, I saw you showing the query language, right? So,
Oh, yeah.
so is there a interface to GraphQL Neo4j, and is that something that you can show?
Wait.
Because it seems like a perfect fit, right? For
Where'd it go? Oh, wait, I'm in there. I keep forgetting I'm in Chrome. Are you talking about this? This, like, interface?
no, GraphQL is like,
Oh, okay, so,
like a standard, right? It's a query language.
yeah.
So, and I was actually doing a quick look up that they seem to be, it seems like a perfect fit for something like this.
Oh, yeah. So,
Isn't that
you can, I'm sure that you could add like GraphQL as a layer on top of a graph database, but really like GraphQL is just another example of like a query language for querying what they say is a graph, but really underneath it, like you're still doing REST, you're still like most people are using GraphQL on top of like SQL, which is what we're doing. So really it's not a graph, but you're querying it graph-like. Because you're querying like a node with, and then I want back like these properties from that node. So yeah, the query, and this is actually an idea I had when I was looking into this, was like, well, what if we took the GraphQL query language and queried Neo4j data using, instead of Cypher, use GraphQL.
We've got an integration for that.
Oh, really?
Yeah.
Nice. So there you go.
Okay.
Yeah, there's a lot, like, I barely scratched the surface with the stuff that you can do with Neo4j and all the add-ins that you can put on there, and I didn't even talk about like deploying this or anything like that. There's a lot of considerations for that. Like I said, I highly suggest you check out their website. That's where I got 99% of the information for this talk. Again, super good documentation. They did a really nice job. So I would suggest looking there if you have questions about that stuff too. Yeah. Other than that, like I said, you're welcome to come talk to me afterwards. But that's it for you tonight. Thank you.
Thank you for coming out. Please grab as much of the food as you can. Otherwise, we have to dispose of it ourselves, and I probably don't need to eat too much more. Again, in 2 weeks, JSTL will be meeting here. We're going to go over the node deployment stuff, building games. That's going to be awesome. And then in 2 weeks after that, STL FullStack will meet here again. I think it's Craig is going to talk about intellectual property and licensing. So if you're into that, that'll be the first talk of that kind. So. Yeah, I think that's pretty much it.
Jennifer was nice enough to bring some swag.
There we
If
go.
you,
I love that.
Everybody likes a sticker or two, so.
Yeah, and hang out as long as you want until the custodian figures out.
I'll kick you out if you stay too long.